crystal lattice. Crystal lattice and unit cell. What is crystal lattice? First understand what is crystal lattice. A regular three-dimensional arrangement of the points in a space is called as crystal lattice and also the space lattice. It is a regular 3D arrangement of the points in a space is called as crystal lattice. When you take for example, when you look at the structure of a diamond ring, this is a structure of a diamond ring. According to you, it is very small, but according to chemistry, it is a very giant molecule. Now think how this giant molecule is formed. They are mainly formed by thousands of lakh molecules, small molecules together form this giant molecule. Okay. Now the crystal lattice. Let's deal with the structure of the crystal lattice. How the structure is. This is a point, this is a point, this is a point, this is a point. Below this is same points. Below these points. Okay, these points are called as lattice points. Lattice points. Characteristics of a lattice points, crystal lattice. Each point in a lattice is called as lattice point or a lattice site. These points are called as lattice points. Okay, each point in a crystal lattice represents one constituent particle, which may be an atom, molecule or ion. These lattice points represents the particle that can be atom, molecule or ion. It can be atom, molecule or ion. We should not call them as a points, but we should call them as a lattice points. Okay, each points in a lattice is called as a lattice points. These points must be joined, then we will get the structure of a crystal lattice. Join these points. Join these points, you will get the structure of a crystal lattice. Okay, this is the structure of a crystal lattice. Lattice points are joined by straight lines. These lattice points are joined by the straight lines to represent the geometry of the lattice. To represent the geometry of the lattice points are joined by the straight lines. Okay, it is a regular 3D arrangement of the points. Look at the 3D arrangement of these points. Cubical structures are joined. Is called as crystal lattice. It is also called as space lattice. Characteristics are these points are called as lattice points. They must not be called as a points, but they must be called as a lattice points or lattice site. Each point in a crystal lattice represents one constituent particle that can be atom, molecule or ion. Lattice points are joined together by the straight lines. They are joined by the straight line to represent the geometry of the lattice. This is the structure of the crystal lattice, definition and some of the important characteristics. We have already understood about the crystal lattice. Now let's deal with what is unit cell. What is unit cell? The smallest portion of a crystal lattice which when repeated in a different direction generates the entire lattice is called as unit cell. It is the smallest portion of a crystal lattice. When repeatedly draw that same structure, you will get the structure of the unit cell. Let me draw the structure of a crystal lattice. This is the structure of a crystal lattice. These are the points of crystal lattice. Join these points. When you join these points, you will get the structure of a crystal lattice. This is the structure of a crystal lattice. This is the structure of a crystal lattice. When you rub these lattice points, you will get one cubical structure. When you rub this lattice points, you will get this type of a cubical structure. You will get this cubical structure. You will get this cubical structure. This cube is the smallest. This cube is the smallest part of the lattice cell. Okay, cube is the smallest part of the crystal lattice. When you repeat these cubes again and again, you will get the structure of a crystal lattice. Okay, this is the smallest portion of a crystal lattice, which when repeated in a different direction generates the entire cell, is called as unit cell. This cell is called as unit cell. This cubical structure is called as unit cell. When you repeat this again and again, this unit cell, you will get the structure of a lattice, crystal lattice. Some of the important characters of this unit cell. Some of the important characters of this unit cells are its dimension along the three edges A, B and C. Look at the structure of a unit cell. This is a small structure of a lattice unit. Okay. Let's represent this as A. Let's represent this as A because it's determining the height. We will represent this as A. We will call this as B. We will call this as B. This as B because it is determining about the length. It is determining the length. And let's call this as C, as it will determine you the width. A will determine the height. This will determine the height. And B will determine the length. And C will determine the width. A will determine height, B will determine the length, and C will determine the width. It's the dimension along the three edges A, B, C. These are the parameters A, B and C. This is A, this is B and this is C. This determines height and this determines length and this determines the width. Okay. This is the structure of a unit cell. There is a sum of the angles are forming between them. Okay, we call this angle as alpha. Okay, between A and C, there is an angle forming between A and C. We call this as a beta. The angle between A and C is called as beta, and angle between the B and C we call it as alpha. This is beta and we call this as alpha, and the angle between the A and B is called as gamma. C determines the height, its dimensions along the three edges A, B, C. A determines the height, B determines the length and C determines the width. Angles between the edges. There are some angles between the edges. Alpha, that is the angle between B and C, and beta, that is the angle between A and C, and gamma is the angle between A and B. The unit cell is characterized by the 6 parameters A, B, C, alpha, beta and gamma. These are the 6 parameters of the unit cell. Can be broadly divided into two categories, primitive and centered unit cells. They are mainly divided into two categories, that is primitive and centered unit cell. First one is primitive unit cells. What is primitive unit cells? When constituent particles are present only on the corner positions of a unit cell, it is called as primitive unit cell. We know that unit cell has 8 corners. It has 8 corners. 1, 2, 3, 4, 5, 6, 7, 8. It has mainly 8 corners. Primitive unit cell. What is primitive? When 8 lattice points. These 8 lattice points are present on the 8 corner is called as primitive unit cell. simples, when 8 lattice points are present on its 8 corners, it is called as primitive unit cells. When constituent particles, what are constituent particles? They are lattice points. When lattice points are present only at the corner positions of a unit cell, they are called as a primitive unit cell. The second one is centered unit cells. Centered unit cells. In the primitive unit cells, we found that lattice points are present only at the corner positions. We know that there are 8 corners at the crystal lattice. But in a centered unit cell, when a unit cell contains one or more constituent particles present at the positions other than the corners, in addition to those corners, it is called as a centered unit cells. Okay, what are centered unit cells? When the constituent particles, what are constituent particles? They are lattice points. When the lattice points are present in a different position, it can be in the middle, it can be at the face, it can be at the center, it can be at a body part. When these points are present in these face centered positions or body centered positions other than that of the corner points, they are called as centered unit cells. When they are present at the middle or wherever positions other than the corners is called as centered unit cells. Okay, centered unit cells are of 3 types. They are body centered unit cells, face centered unit cells, and end centered unit cells. Type of a centered unit cell is body centered unit cells. Such a unit cell contains one constituent particle, atom, molecule, or ion at its body center besides the one that are its corners. We know that crystal lattice consists of the 8 corners, and there is one lattice point. There is a lattice point which is present in the center. It is called as a body centered unit cell. When the point is present in the center of the crystal lattice, it is called as body centered unit cell. Unit cell contains the lattice point at its body center. It can be here, it can be here at the center of the body, besides at the corners, not in the corners. It is called as body centered unit cells. Centered unit cell, this is the second type of a centered unit cell. Such a unit cell contains one constituent particle present at the center of each face besides the one at its corner. Okay, there are 8 lattice points. In the 8 lattice points, first we should know how many faces are present in the cube. How many faces are present in the cube? There are 6 faces. 1, 2, 3, 4, 5, 6. There are 6 faces present in the cube. We all know that there are 6 faces present in the cube. In a face centered unit cell, there is a lattice point on every face. There are lattice point on every face. There are 6 faces, so there are 6 face centered unit cells. Okay, 8 lattice points at the corner positions and 6 lattice points at the face centered positions. These are called as face centered unit cell. When the unit cell is, when the lattice point is mainly present at the center of each face, there are 6 faces at the center. It is called as face centered unit cell. Type of a centered unit cell is end centered unit cells. End centered unit cell. In such a unit cell, one constituent particle is present at the center of any 2 opposite faces besides the one present at the corners. If you have a lattice point, on the opposite faces, it is called as, if you have a lattice point on the opposite faces, it is called as end centered unit cell. Consider here you have a lattice point. In the end centered unit cell, you must and should have the lattice point opposite of this. If you have a lattice point here, you must have here 2 on opposite faces, but not at the corners, only at the opposite faces. This is how they are classified. Unit cell is classified. There are 7 primitive unit cells and their possible variations as the centered unit cells. Crystal systems, there are 5 crystal system: cubic, tetragonal, orthorhombic, hexagonal and trigonal.